Let's take a look at how we can divide rational expressions. And unfortunately, division always takes a little bit extra steps to set up the problem and then solve. Division, that's what this represents. So I have this rational expression, I have this fraction, and I'm dividing by a fraction. Whenever we divide by fractions, it's always a good practice to recopy this differently. I hate to divide. A lot of the process that we talk about, we change division into something else. And that division needs to be rewritten as multiplication. So remember, whenever we started dividing fractions, somebody probably told you that you should recopy the top, take the denominator and flip it, and turn it to multiplication. And that's exactly what we're going to do here. So I need to take this denominator and flip it upside down. 5a minus x, it's still a fraction, and multiply it. So now all of this has been rewritten. This is now my new problem. So if your question says to divide by a rational expression, you want to take that denominator, flip it, recopy it perfectly, just flip it upside down, and change it to multiplication. Now, with multiplication, we can multiply across the top and across the bottom. But I don't suggest you do that yet. What I like to do is I like to look now at each piece and see if there's not something that could be simplified. X squared can't be simplified. 5a minus x cannot be simplified. So those are going to be written together on top. 25ax squared minus x squared, forgot that squared part, can be simplified. It's the difference of two perfect squares. So that's factorable. Another heads up, another hint, we typically are asked to solve or simplify these types of expressions with the anticipation that something should simplify. That's kind of the point. So if you notice a 5a minus x up here, I probably should have a 5a minus x somewhere down here. And I'm going to get it from factoring this. That's just a hint, a heads up. A lot of times your rational expressions will factor or simplify. So I'm going to write down what the results of all that should be right here. So x squared we said was part of it. 5a minus x is also part of it. And I'm going to write that in parentheses. I'll write this one in parentheses. Those got pushed together. This needs to factor into 5a minus x and 5a plus x. And then x comes along for the ride. Those got pushed together. Now I want to start eliminating perfect copies. I have a 5a minus x on top, 5a minus x on the bottom. Exact copy. Cross that out, cross that out. This is an x squared. That means I have two x's on the numerator, x and x, and I have an x on the denominator. So this one is allowed to simplify or cross out with one of those. So if I scan over everything else, and here's kind of like a major exclamation point, like red flag should go up. A lot of students want to eliminate this x, this plus x, with this x. And a lot of teachers want to scream, they want to say, wait a second, you can't do that. And the reason for that is this x is attached to 5a. Once that attachment takes place, I need a copy of 5a plus x in the numerator. So if there was a 5a up here by itself, don't eliminate 5a down here. It doesn't work that way. I need an exact copy of this statement right here on top. Just like I did here. They were exact copies. So just another hint. Be mindful of what you're going to eliminate. You may start working very fast on these problems and start crossing things out, eliminating things that don't actually eliminate. So I've done as much as I can. So I'm going to write an equal sign. And this equal sign is to represent what this simplifies into final answer. I have an x on top a 5a plus x on the bottom. Again, do not simplify this x and x. That's as far as I can take this example. A lot of people like to write restrictions on the denominator. You cannot divide by 0. So we don't want, in this case, we don't want 5a ever to equal negative x. And if you don't understand that right now, that's okay. Sometimes there are values down there that we can solve for differently. I'm not going to worry about the restriction on this one. It's more about the process of simplifying a rational expression being divided by another rational expression. So think about what we did. We took this denominator, we flipped it, made it multiply. We looked to now simplify each piece of that multiplying expression. Did not simplify, so I smushed them together. Did simplify, I factored it. Did not simplify, smushed them all together. Copy, copy, eliminate. Copy, one extra copy, eliminate there. Write down whatever's left over in fraction form, and you've divided those rational expressions perfectly.